Not only are comets absolutely beautiful, they're also totally fascinating. They contain chemicals and compounds that have been frozen in time right since the beginning and the origins of our own solar system. Today we're going to cook a comet nucleus. It's not perfect, but it's a pretty good model of what a real comet nucleus would be like. They're often called giant dirty snowballs, and so we're going to start by adding some water, plenty of water. There we go. Now what do we need next? I'm going to put a bit of sand in. They are mostly water and carbon dioxide, but I'm going to put a bit of sand, silicon dioxide, in here just to represent the silicaceous material that you get. You'll find ammonia in comets as well. Now, it's quite hard to get hold of ammonia, it's a nasty poisonous compound, but you get ammonia in cleaning products. So a bit of ammonia going in here. Interestingly, you get alcohol in comets as well. Not much, but you do get some. It's quite an interesting find. There's a splosh of alcohol. And then these are the really interesting chemicals. I'm using some soy sauce here to represent the complex organic chemicals that you find in comet nuclei. Amino acids, bases, complex hydrocarbons. Surprisingly, they're all there in comets. It has made people wonder if it's comets that have kick-started life on Earth. And to underline that, we're going to put our penultimate ingredient in, some graphite. This is carbon, and we are, of course, carbon-based life forms. It's interesting to speculate that the carbon atoms that make up your body may indeed have come from a comet. There we go. We've got most of our ingredients in there now. Just give them all a good mix up together. And now I'm going to add in the final ingredient, which is dry ice, solid carbon dioxide. This is where the reaction starts to get quite interesting. So I'm going to think about safety and put my goggles on first. Okay, now I'm going to add my dry ice to my water mixture here. And you should start to see sort of a Harry Potter effect here as we mix together the water and the dry ice. It's important to give it a good mix. I need to mix all these ingredients together and get them all into contact with each other. Of course, the dry ice is at about -80 degrees C, so it's immediately cooling down and freezing the water, and hence I'm going to get a good of a snowball effect here. Sometimes it spits out a bit. Because it spits out carbon at you, you can get a bit mucky, which is why I'm wearing my lab coat. Now, I think it's almost ready. Just going to put my gloves on and give it a bit of a knead together. Let's see if I can turn out my comet nucleus, and we'll have a look at what it looks like. Whoa. So here we've got our comet nucleus. You can see that it's solid. It's composed mostly of solid water, ice, and solid carbon dioxide, dry ice. You can see that also that it looks quite grey and black on the surface. That's because of the carbon. And in fact, as this comet comes near the sun and warms up, and the ice and the dry ice evaporate away, so they'll bring the carbon up to the surface of the comet, and this comet will become blacker and blacker. If you've ever seen a close-up picture of a comet, you'll see that they are pretty black and dirty, black, dirty giant snowballs. So this is our recipe for a comet. Of course, we know that comets do come in different shapes and sizes, and they have different compositions. Some comets are more rocky, some comets are more icy. ESA's Comet Chaser, the Rosetta mission, is unlocking the secret chemistry of comets and helping us learn more about the origins of our own solar system.